Welcome. Good afternoon, everybody. Welcome to a new webinar from us from Dental Access. For the ones who don't know me, I'm Jeroen Klijnsma. I'm the digital specialist and a certified dental technician for the company Dental Access. Together with me, I got my colleague Matthew Thomson. He is our product manager and head of support.
Hey everyone.
And thank you for joining in, Matthew. Perfect. So today we would love to go through some different workflows, and basically the workflows are all fully edentulous implant supported restorations. And we're going apart into design, but also a part of manufacturing. We all know that a lot of these designs take many minutes, many hours, to be honest. So we've done the recordings with it, but we go through the recordings with you just to speed things up. Otherwise, it will take way too long. But I hope everybody can understand. Let me directly dive into it. And I am going to start with the agenda. And we've done the introduction. I've introduced myself and my colleague. After that, we're going into design for the direct to fixture, like on a titanium bar. There are different workflows in that one. Then we go into design a hybrid-based case, and that's on tie basis. Matthew is going to talk a lot about manufacturing by milling, manufacturing by 3D printing, your post-processing, and of course we have training solutions. So if everybody is ready to go, I would love to dive directly into the first one. And the direct to fixture. And there are different ways into designing it, like I said previously. And we can make removable on top of a bar with an overstructure. And there are different ways in doing that already. We're going to show you a small version of the crown and bridgework model you can use, the RPD module or the denture module, because not everyone has got all the modules, but with these, you might have a big chance you can already do part of it. Another option is go for a wraparound bar. That takes normally a little bit more manual labor, but it's a really good solution. You see it in the in the bottom right picture, and you see more wraparound. There is another function that's called a split file. Without the gingiva is that, so you have the titanium part direct to fixture. On top of that is like a bridge or a crown. And we got a Tembo bridge. The three below I'm not going to demonstrate today. We're going to stick with the top three, the crown and bridgework module, RPD module, and the denture module. Let's go from that point. And then we're gonna go for a hybrid on tie basis. In this case, monolithic, using implant bar and bridge module. This is done by one of our clients in Sydney. He's from the Oral Design Group, Thomson, and he made beautiful, fully monolithic all-on cases. It's an all-on 5, beautiful, fully monolithic zirconia. Just added some pink ceramics, and look at it. It's a beautiful high aesthetic with really high strength and zirconia. So I want to directly go into the design direct to fixture. And like I said previously, we've recorded the video. We go through it, and we're also able to pause, and I'm going to tell you a little bit more about things. So let's directly start direct to fixture on a bar design. First, we want to have a beautiful bar where we can work on. There are a lot of customers of us also asking, how can we do those things? They see it coming from a milling center or a special design center, and you can do it yourself. There are ways in doing that. So let us go through it. First of all, I'm going to show quickly what the order form is. So we select the implant. There we select, it's a customized abutment. We select the implant library. For this case, this is a beautiful case with ELOS library. And they can have a direct to fixture, because then you can do your own manufacturing, for example. From that point, we select a bar bridge, and we're going to go and continue designing. I'm going to do a redesign in this case, but it's still the same steps. sorry, that was the wrong button. So what I would love to show also is, let me quickly go into it for a split second. And on the top right, we have a function, a pre-scan or pre-up. And with that one, what we did previously is we created a file, temporaries directly on the model, and that gives us already the teeth location. So a lot of times you already start with a patient who has a denture, for example, or it's gonna be extractions and then directly to create something on that one. So we created that up front to make it us a little bit easier and the designing go faster. And that is basically copy, append, design. And also one of the functions will be anatomic for reuse, or basically design for reuse. So we go from that point, this we already have. I'm gonna redesign. There it is. There we already have the design. So we know if it's, for example, let's pretend it's an existing denture, we know where we have to design our bar directly into the right area. There is something, I don't know why, but sorry for that one. Again, here we do the occlusal alignment. We go next, we select the annotations. Where are the implant position here? Where are they based? The insert direction. And there is a profile. What we have done is I've created a profile previously. So you can do that on the control panel of the software in 3Shape, and you can create your own beautiful profile. And from that point, you directly go into your design. You can adapt wherever you feel like, and so on. So yeah, luckily it worked. Now we put everything in position. We sculpt everything. And this is a very nice part, is you can go sculpt it directly towards the gingiva and make a beautiful metal bar like that. But this takes some time. Don't expect it to do this just to do this in a split seconds. But make sure you have the right connection. It looks okay, it's all closed. Then what you can do is basically do your angulation screw hole. So if you need to change that position of your screw hole, the angulation for that one, this you will do it in this stage. So this gives us the base for the overstructure actually, on that one. I'll continue. And there we see the screw holes again. We can change everything where it's needed. It's doing the calculation. We can finalize by adding and removing, still finalize your beautiful design. And that gives us a fully designed titanium bar. And on top of that one, we're gonna create our designs. So now we're going to direct to fixture, and we're gonna use the crown and bridgework module. With the crown and bridgework module, there are ways into doing that. So what we did is, one of the steps is you can basically copy the original bar design, copy, append, design, and work on that file as your new preparation file, as your new work model. So we're going to show you also in the order form what to select. Oh, and it happened again. Sorry for that one. So what we are seeing here on the left side, or basically in the middle where all the teeth are, you see the first part one. We're going to select the coping that is outside of the scope of your design. And that is a coping that goes basically on top of the entire bar. And then on top of that, we're going to create crown pontics, and we're going to merge them all together as a bridge. So it's all merged together. And from this point, we'll show you how it's been done. And select coping, crown pontic, and work from that part. Again, occlusal alignment. So if we need to sculpt something on the jaw, we can do it in this step. Again, annotations, select where it is, insert direction. Okay, and here we are basically gonna select the entire margin line. As you can see on the screen, it's in this case, it's red. That is the entire margin line we're creating. And that is where the end of our coping, coping what we did, will end. So from that point, we continue. It's crossing undercuts. Some areas a little bit no, but that's no problem. I'm gonna create a cement gap. And from that point, and this is the good part, is when we did the teeth setup initially, it directly, you can use an anatomy for reuse, it directly comes in here. So you got already the right position. And this works really well if you use that function for everything that's crown or bridge work or RPD related. For the dentures, it's different because unfortunately they're using in 3Shape a different library. So you got the small library for normal crown and bridge work, and you got the small library for the denture work. But for the crown and bridge work, this works absolutely beautiful. I'm going to continue in this one. I'm going to design everything. This is a good function that is, I showed up here, that is the 0.10% on the contact and smoothing, is my distance to my gingiva. And in this case, the gingiva is the design of the metal bar. So you want to make sure there is space underneath. So you create distance between your teeth and your model. And here you can see that is where you basically got your cut out. And here we got our design already. Don't get me wrong, now you directly see the gingiva, that takes some designing. So it makes just a flat coping, basically a flat layer on top of it, and you have to design on top of it. So yes, it is some extra design work, but you are still able to design something in just the crown and bridge work module. You don't need that advanced thing. It is some more work, so yes. It's definitely, you have to realize that one. I'm gonna go next. One of the options we have is create cylinder holes. You wanna do additional cylinder holes. So when you, basically you can bond this restoration, this design on top of the bar. You still want screw holes. You're going to use this function, parametric shapes, cylinder hole. I prefer always working from a view direction, gives me a little bit more control. And here you can basically put it in position and go from that point. And there we got our bar completely, or basically overstructure completely designed on top of that one. And this is design part 1, so using the crown and bridge work module. We go from that point, close, and we do our cam output, and we got a beautiful STL file to work on. Okay. That is the other one we have is direct to fixture, is the RPD module. RPD module you can also use to design it, and let me also take you through everything. And the RPD module, I'm going to show you also what we used in the order form. So we selected a crown pontic, an RPD frame, and what we did also is basically copy the anatomy for a reuse folder from a previous one into this one, so I directly have the teeth set up. You see, there are also on the back end multiple things you can do. Let me continue. And in this case, again, redesign. You're gonna have the annotations, and this is one of the models that is copy, append, design, and you work on that part. And there are also different ways in doing that, creating a file, as long as it's a so-called watertight from the top, you are able to design on that one. The surveying blockout, insert direction technically. We can add and remove some wax trimming if we want to do that. Here you see directly we got the teeth already set up. That makes it so much easier. So if you have a case you've done earlier, you can, if it's still in the same direction, you can copy that entire design and take it to a new case. I do my major connector, basically my entire outlining. And there it is. So we saw the step also, and it's the same. Let me try to get it. There it is. The same step as when we use a coping. It puts a layer on top of it, and I have to design everything here myself. Again, it is a little bit time consuming, but it definitely is possible, and it's good training, of course. And there we've designed our own new gingiva around it. And with the add and remove tool, smooth tool, we can make those things happen. And the sculpt RPD design, you can even do more finalized design you can put into that one. And here I put in 3 of them. I did use the same option, same function. And I've already put, if you look on the screen, I have already put in 3 cylinder holes and extruded them basically from my design. So you can use the same option in here. I can put pins in between if you do, for example, if it's a lower arch with further extensions, you want to avoid that there is any additional shrinkage or more support during manufacturing, especially 3D printing. You can put that even in there. And here you see complete that part. That is your complete overstructure. That one you can use for your manufacturing. Okay, that's already another one. And we've got another one that's with the denture module. The denture module is absolutely also great for doing this type of work. So in this case, we're saying artificial tooth. We're going to select the gingiva and we're going to bridge them. And we can select there what kind of base do we want, artificial teeth, monoblock, or design teeth. If we do in the newer version design teeth, it already puts out 3 files to be honest. And what it will put out, it will put the teeth, the gingiva, and it will also put out a monoblock. Again, here, this is the same pre-design I've used. So especially for denture, it's perfect because I can design my teeth as much as possible already in this one. That helps already with your design. So basically, this is the occlusal plane, and it happened again. So this one is the next one, tuberosity, incisive papilla, tuberosity 2, and the 2 canines we're gonna select. And we go from that point. Here also we do the upper jaw boundary. That's basically the end of your design of your gingiva. We can do that perfectly in this one. Surveying and block out. Again, your insert direction. Setup of teeth. Here I can choose the type of library I would love to do. That is a beautiful one from Fabulous Smiles. There are different ones. You see different designs. And you can really beautifully use these ones. If I selected the right library, I set my teeth up correctly. It gives a gingiva lines penetration. It penetrates over there. We are aware it's gonna be removed anyway. And now we are basically in the part where we design already the new gingiva. And in the latest version of 3Shape, they've created a new module or new function actually inside the gingivator. And that makes it so much easier to create a really good aesthetic gingiva. And I quickly go through everything, and you will see the differences a little bit. And it makes designing so much easier. Where my cursor is at the moment, at the base thickness within material settings, I say it's 2.15 millimeters thickness, and I go from that point. Here I select if I want a delicate, a natural, or an intense way of designing. And here I can select even in them all of those options. I can create the interdental differences, the root differences, gingival margins. I can change everything like here. I've chosen for the middle option. Drill compensation is very important when you do your manufacturing. Mitch is going to tell you definitely about that one. So keep that on the back of your mind, please. So what I've done here is I've bridged them all together. On the left side, you see the connector settings. I put the facial scale to 70%, lingual scale to 100%, and the center scale to 60. In this way, I know for sure we get the most beautiful designs and the most beautiful connectors. So it's not all on the buccal area where it's all in plain sight. But that's what we want to avoid, of course. I'm gonna continue. Now we can still sculpt everything. Also here you see the red and the yellow. That has to do with milling settings. How far, how detailed a milling can go. Sculpt of the denture base. Here I can still make all my adaptations. If I have done my perfect design, I'm like, okay, we go next, and we go into coupling mechanism. And coupling mechanism is technically what that is basically the insert direction of the tooth arch. I don't even know, thank you, into the gingiva. So you can think about if you put it up straight, you get up front in the buccal area very thin gingiva, so you will see much sooner the basal area of your teeth. If you put it in this angle, you create much more space between the lowest part of the basal area and your gingiva area, so you block that basically, see it as opaque, your dentine, it's, or sorry, not dentine, but really opaque, it blocks it out, so you don't see it as much, and it gives a much better result. This is definitely possible when you're working in bridges. When you have single teeth, it doesn't work like that. But if you work in bridges, even if it's 1, 2, 3 bridges, it all depends on how you want to design and manufacture. You will have this option activated. So we go from that point. And this one is also a nice one that says the minimal thickness under the teeth. So under the teeth, it will be minimum thickness of 0.8 centimeters, and we want a glue space of 0.1 millimeter. All of that, all those settings, we can definitely help you go through all these. Again, drill compensation also is there. That has to do with if you do manufacturing by milling. And here you see the teeth, completely teeth arch, and there the gingiva with all cut out already, so for a perfect repositioning and a perfect fit. And that is basically how you design an overstructure with the denture module. And that one is closed. Also going to show you a little bit when you do the manufacturing output, when you create the STL files. And like I said previously, you're going to create 3 files. One of which are all the teeth. One of them is the gingiva base, and the other one is a monoblock. And that's what we're going to show you next. So here we have the 3 STL files. First one. All the teeth. This one, let me open all of them. So it doesn't line completely up in here with the teeth and the gingiva, but that's not necessary because they're going to be separately manufactured. And this is your monoblock. And you can use this to print or mill out of one material directly all combined. It all depends on what your end result is going to be and what you want it to be. If we've done this one, we have one more left, and this one is basically an all-on system, on a hybrid system, and it's based on tie bases. And tie bases, it all depends on your type of library, your provider, and everything. So please feel free to contact us also about that. We can help you with the right parts, as we are also dealing a lot with ELOS, for example. Again, we're going to show you the order form, and we're going to select the implant parts, all of that, what it's going to be, the gingiva, again, all the other are crown pontics, and we're going to redesign occlusal alignment. This is a design I did previously in the 2019 version. With this one, I don't have that preset teeth, but this is a previously design we did, but it shows you perfectly what it is. Also select implant positions, insert direction. Here I've put an anatomy pre-design already. We're going to design basically our emergence profile. We do that for every implant in this case. So we go through all of them, make a beautiful emergence profile. As soon as we've done all of that, we're going to finalize our anatomy design. Now we can extrude everything, we can add and remove. Then we're gonna select our gingiva outline. And draw the outline over here, how we want the gingiva. And we're gonna also create some areas that the software doesn't create your gingiva, so basically where your screw holes or your implant position will be. You don't want any gingiva over there. Then if we go into the next step, we have our gingiva anatomy. So here we design also fully our gingiva. With the teeth in. Here we're gonna completely design that one. And this is with the crown and bridgework and implant modules from 3Shape. Also in this case, how we can sculpt anatomy design. Here also this shows with your milling burr, the 0.5 millimeter diameter burr, it can get into certain areas, yes or no. Also Matthew will definitely take you through that. And then we go into the assembly. And assembly is again the implant position, or basically the the angle screw hole. And if we need to change them, we can change them here. Not every implant can do that technically, but a lot of libraries are allowed to do that. So you have also the warranty from the manufacturer. If you do that, that doesn't give an issue. Here you can change them. Most of them, yeah, it really depends, but they go between 15 and 28 degrees. And as soon as we have our design ready, we say close, and we can hit that one basically towards our milling or 3D printing systems. And from that point, we can do the manufacturing. And as soon as that has been done, we basically put in our tie bases. We're gonna bump them, and we have a beautiful case ready. So this is really fast going to all the steps like, hey, how are you going to do your designing? So now I would love to give you to my colleague Matthew, and he will gonna tell more about basically the manufacturing. Matthew, I'll leave it.
Excellent. Thank you, Jeroen. Thank you, everyone. Very insightful stuff from Jeroen. All the different ways you can skin the same cat effectively. You want to have a design to manufacture, and there's many different ways of doing it. So it's a really great way of getting to the STL stage. So what I'm going to talk about a bit more now is how we're going to mill or how we're going to print. Three main steps: CAD, CAM, and finally CAE, so computer aided engineering. We've done the CAD, we're going to cover the CAM, and we'll also cover a bit of the computer-aided engineering. Computer-aided engineering is where we're talking about materials and some post-processing options as well. So yeah, as I was saying, you've got your beautiful STLs, but you want to manufacture them. So what do you need? You need the right advice. So someone or a company that can provide you advice as to which material is TJ approved, which materials are going to be good for your particular milling machine or printer, what compatibilities are there. Also the right support. You'll absolutely need after-sales support. So if you need advice on how to sprue something, whether it's milling or printing, or if there's a certain workflow you want to optimize, or timing it, do you want to mill the teeth during the day and then the denture base overnight? Having the right support and advice is critical in that regard. Also the right equipment. If you've got a small 4-axis milling machine that you use to make Emax crowns, that's not going to do the job for milling a full denture base. You're going to need a much stronger spindle. You're going to need a 5-axis machine, something that can handle the wear and tear of milling a lot of plastic. As we know, plastic and PMMA is a very dense, strong material, so it takes a lot of effort to cut it. So you do need a bigger, stronger machine to do the cutting if you're going to be doing milling of plastics 24 hours a day or a huge amount. You need to get a big grunty machine and the right material. Of course, we said you need to have the right TGA approved materials. If you're going to put this in someone's mouth, then it has to have TGA approval, or MedSafe in New Zealand, or whichever regulatory body is in your country. And that's all these questions are something we can provide. So if you do have any questions, please do reach out. So we'll move on to the next slide now. So equipment, open and optional. We've spoken about CAD today, so Jeroen took us through the 3Shape software and all the different modules there are there. Manufacturing for milling and 3D printing. Is it open? Can you take any material from any country in the world and pour it into your printer? Will it work? Can you take any disc of material, your 98mm block of pink material, maybe it's from America, maybe it's from Germany, does it fit into your machine? Or do you have a barcode limitation on your machine that locks you into certain materials? Also, the post-processing. Do you have certain alcohols that you need? Do you have certain brushing techniques that you need? Do you have a certain post-processing flash unit that you might need in order to get that TGA approval? So this is something you really do need to think about before you get into the world of full arch overstructures. And on to the next slide. So let's talk about manufacturing by milling. We have a few options here. We can mill the base and we can mill the teeth. And that way you can mill individual teeth, or you can mill a full arch of teeth, or you can mill some smaller arches of teeth. Maybe you want the posteriors to be a B2, for example, whereas you want the anteriors to be an A2. You could mill 3 small arches. Also, which library of teeth are you going to be using? Some libraries let you use whatever library and then you can morph it into a bridge, whereas others, they restrict you to only having their card teeth. So this mixture of all the different ways you can construct teeth for milling is important to consider, not only in the CAD, but also in the CAM. If you think about which milling machine you're interested in using, you can have something like a Roland DWX 52 DCI. This is a great workhorse for doing your zirconia and wax, and many of you will know it's a very reliable machine. It's got a 6-loader stacker on the side, so you can load up to 6 blocks. It's good for doing a decent amount of PMMA, whereas if you're looking to do a huge amount of PMMA and possibly metal as well, if you're milling your titanium bar and you also want to mill your dentures and teeth as well, then something like an IMES iCore 350i Pro Plus would be the machine to go for. It's got a much stronger frame that's made out of a polymer cement rather than aluminium. It has some linear encoders along each motor, so you can compensate for variations in temperature to ensure that your titanium bar has very, very accurate interfaces, so that when you do your Sheffield test, this passes the test. Also, it's got a really strong spindle, looking at 2.6 kilowatts, and it's even got water cooling, because it is such a strong, grunty spindle. You do need to have that coolant flowing around the spindle to keep it cool and to keep it milling optimally. So a few things to consider when you're milling your teeth in your base. If we move on to the next slide now, we'll look at manufacturing by printing. Oh, we've jumped. No. Sorry, no, we've jumped, so that's all right. So here we are, we're looking at the workflow of how to mill out a denture base. So I've loaded up my mill box for Roland, and you can see I've just got some crowns here from a previous job. So we'll quickly go through the video and we'll watch the workflow for loading in a denture base. So at the top right, we select new job. And then we're going to choose our machine. So I'm going to choose the 52 DCI. I'm going to choose some PMMA and click the green tick. Next up, I'm going to import my STL. So here's all the cases that Jeroen designed earlier. Just like any good TV chef, here's one I prepared earlier. And we choose our object type. This object type is bridge or denture over bar. So there's a very specific object type in Millbox just for this type of work. And this is only a recent addition in the 2020 version. So if you're running a 2017 or 19 version, you might not notice it. Also, with the new versions of Millbox, you can choose your own colored blocks. At the top right, you see the pink block. Also, we can see here these pink circles going around each socket. This is a really critical part of milling, to have these sockets identified by the software. So when we have our STL from 3Shape, we also have our PTS. So we go and choose our block. We've got our dark veins. I've chosen that as a name, and lock code. We enter the lock code, which is the number on the box for batch records. And then we load that in. It's going to load in some sprues, and I'm going to say, no, I want to do my own sprues. So I'm going to click on the object, click the plus, and I'm going to add in a few sprues. One at the side, one at the front. I can also automatically hide the frame, and I can put my sprues wherever I want. You can see that white line going around the object showing me where the optimal place for the sprues is as well. Then we're going to flip the object over and look from underneath. And you can see here, there's a few areas which are slightly undercut. Now, it's really critical that we ensure that our milled denture fits onto our bar. So I'm going to rotate the denture backwards So it's at an optimal angle for milling. And you can see here, now those undercuts are gone, and I can start my toolpath calculation, choose my adapter code, D for denture or D for dental access. Also, I'm going to choose my 3+2 milling option. So all my undercuts are taken care of by the milling strategy. And this is going to calculate away. Now, I've shown in this video here the performance of my computer. You can see I've got many CPUs in my computer, and you can see there's a huge amount of work going on in your computer specifically for Millbox. So for that reason, we recommend you have a dedicated computer with a really new CPU, 8 cores or more, and a nice fast SSD to ensure your calculations are done really fast and can help make your workflow really efficient. So that's how we mill just a denture base. Having the pink base is really nice to have, ensuring we've got the undercuts and ensuring we've got that PTS file to give us our sockets. So as long as we've got those three things, we're going to have a really great milling result, irrespective of what machine we use. Now let's move on and we'll go look at how we can mill out the crown and bridge example that Jeroen designed for us before. So as before, we select new job, and then we're going to choose the same machine, the 52 DCI, and I'm going to do zirconia for this one. Choose my disc adapter rather than my pin adapters, and go and choose my crown and bridge design. And as before, we choose the bridge or denture over bar type as our object, and that way it's going to read in all the files that come from 3Shape, three-dimensional shape, and the PTS file to give us our margin line. So let's just play through this video. I think it's just jumped back, so we'll just catch up again. Good to see again. Choose our job, choose our material, and then choose our object. You can see there's a wide range of materials available for the 52 DCI as well, zirconia, plastic, and wax, etc. So here we go, we've got our over denture from our crown and bridge example. Choose bridge or denture over bar and load that in. Once this is loaded in, we can see here that this large pink line going all the way around the margin line that we designed has been identified for us. And we've also got this small pink arrow that we can see has just come up on screen. This shows us the insertion direction of the overstructure down onto the bar. And this tells the milling software to take care of this angle and mill at a certain angle to ensure that we don't have any undercuts. Because again, it's really important that we have our overstructure fit down onto our bar, and especially if we're milling zirconia, we don't want to be grinding away after the sintering process. And you can see here, there's just a few undercuts as well that we want to ensure we get rid of. So it's going to be taken care of again by that pink arrow. And at the front, there's a few areas which the mill can't quite reach because I've got a small air gap. So I'm going to go in here, change that air gap around the restoration to 4 millimeters, and we get a much bigger area. So then our tool can tilt and go in and mill those areas. So that's just a quick introduction to how we set up a job for milling. Very good. Now let's have a look at the printing side. So if we're going to say, rather than mill the denture base, maybe we want to print the denture base. So as before, we can print base, we can print the teeth, or we can print the base and mill the teeth, or we can print the base and have some pre-manufactured card teeth. Many different options that you can compare. We can see here the Asiga Max UV, that's the workhorse, that's a super popular printer at the moment. And we can see down below, there's another picture with a whole lot of denture bases. You can see quite a few of them are fitting on the platform. You stand them all up with a bunch of supports. We'll cover that again briefly. And you can see there are some horizontal T supports just to ensure there's no flex of the denture base while it's printing. So a lot of things to consider there. So let's move on to the next video now. So we start a new job. We open up Composer, new job. We choose our printer. I'm choosing a virtual printer here, and you can see here I'm choosing my material. My Ceremco material is a great denture-based material. That has a slice thickness of 50 microns to ensure we get a great accuracy of our denture base for the fit of the denture onto the bar, also the teeth into the denture. So we choose our denture design from before, the one that we milled in the pink. We load this in, and we can see it drops it into place. So what we're going to do, we're going to drag it, we're going to pull it into the middle of the platform, swing the view around, and then we're going to lift it up and put it above the platform. But what we want to do is orient it in a good direction so that we can minimize the number of supports that are going either into the fitting surface of the denture or into the socket. So you can see here I've rotated it to one particular angle so that the distal areas are pointing away from the platform. Now I've gone into the support generation, and I'm changing the material strength here. So stronger the material, the fewer supports we need. There's a bunch of other settings you can change and play around with to find what you want. So once I've got my settings, I can click apply, and that's going to quickly generate for me the support structures for this particular orientation of the denture base. We can see here as the screen rotates around that this is a fairly good setup, but you can see there's a few too many inside the fitting surface. I don't want to spend my time having to clip them out and burr away. So I'm going to remove the support file, swing back to a parallel view, and I'm going to rotate the denture base to another orientation this time. And we'll see how the supports then generate for this second given orientation. Maybe 10 to 15 degrees away from the horizontal, whatever angle you decide. There are different ways to do this, of course. If you want to print many on a plate, you have to turn them more vertical, but if you want to print them quickly, you put them flatter so there's less height and it will print faster. So again here I've decided to sacrifice the socket so they're facing down towards the build platform and they're getting all the support, but then inside we've got that fitting surface which is really beautiful and free of supports. But when we look below, we can see there's heaps and heaps of supports here. There's a really dense forest, so that might not allow for very good resin flow between each layer. So what I'm going to do here is I'm going to change the support spacing and push this up to a number, 5 millimeters, for example, and then recalculate the supports, and it's going to have a bigger spacing between the supports, so we're going to have fewer supports. If you're doing fewer supports, you might want to make each support larger, so we can see here there's not as many supports, not as many to remove, but still enough to ensure we get a really good print and we have good accuracy, we don't have any debonding, and it's successful. So we apply our supports now that we're happy with our result. And we can even save these settings as vertical or horizontal, all the different options you can choose. So we've got our supports, set them up, and now we're going to go and click the green play button, and we can see there that we've got 2 hours and 37 minutes. What I'm doing here is adding a shadow baseplate or a bounding box baseplate. This baseplate is going to print a slab on the platform before it prints the rest of the object. We can also add some hexagonal holes, and this way we're going to have a nice firm print. The first layer is going to stick to the platform really well, and we can have some hexagonal holes to save a bit of material. We can give it a build name, and we can see all our parameters, and then once this is done, we can send it off to the printer and hit go. So that's a quick overview of how we can load in a denture base into some CAM software like Asiga's Composer, and how we can make a decision on how we're going to orient the denture base. Do we want them standing up so we can fit lots on a plate, or do we have them standing up so that we're protecting some of those sockets or fitting surfaces from the supports, or do we want to print it really quickly so we have to rotate it down, in which case we need to ensure we make a conscious decision of where we're going to put the supports, and we can play around with the numbers and the size and the spacing of these supports. So some things to consider when you're printing a denture base. Excellent. So let's move on to the next slide, please, Jeroen. So post-processing. This is a very critical part of it. You can go online, you can go to many different suppliers, and you can buy any material you want for 3D printing. You can buy an A2 shade, you can buy a light veins colored shade, all the different colors and strengths and biocompatibilities. But when I say biocompatibility, we have to be very specific here. It's not just the bottle of resin that you buy, it's the whole workflow. So for example, with Ceremco, the Swiss company that make their thick, very strong denture material, that's a liquid resin that's got little glass beads inside it. Beads, you think, oh, maybe it's the size of a necklace. They're actually really, really tiny, down at the 100 to 50 micron or even smaller level. These glass beads and the really thick resin ensure that you have a really strong result when you post-process it correctly. So for Ceremco, you have to use an Asiga because this is a printer with the power settings, the exposure settings, and so forth that have been validated by Ceremco, and then all CE, TGA, FDA, etc. Then there's the post-processing. So many of you will have used a wash, like we see in the bottom left of screen here, a form wash, where you take your object, drop it in, swirl around some isopropyl alcohol, take it out, dry it, cure it, done. Whereas for the Ceremco, we have to be very specific about it. We have to take a brush and a certain alcohol and brush off any extra resin. And this is, again, part of the TGA workflow. Then we have to use the correct post-processing unit for curing. Here we've got a photo of an autoflash. An autoflash is different to a cheaper regular curing unit because it flashes rather than has a steady light. The difference being the flash pulses many times a second. So if you think it can have a very short but very high intensity pulse. So if you go pulse, 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 you can put a huge amount of energy in and have a really good cure for a very short time. And then you do it again and again and again. This means that your overall average power is much higher. Also, your curing depth into the material is much deeper. So you have a much stronger cure to help you with your TGA approval. Furthermore, you also pump nitrogen into the milling chamber. In this photo, you can see there's a small transparent area around the chamber. And we pump nitrogen in there. The nitrogen will push all the oxygen out. And when the curing takes place, we don't want any oxygen at all because the oxygen, if it is present, can change the chemical reaction when we're doing the curing. So having a good post-processing cure unit like this autoflash is vitally important for many different materials. And if you look at your bottle of material, you'll often see there's some writing on the side that says you must follow these certain post-processing procedures. So it's really, really crucial to remember that for some materials, such as the Ceremco, it's not just the bottle that has the TGA approval, it's the entire workflow. The bottle, the printer, the wash, and the cure all together make that approval. So we really want to ensure that everyone understands the post-processing is not just wash, cure, done. It is a vitally important step to ensure that we have no spare monomers and we get a product which is fit to go in a patient's mouth. Excellent. So let's look at the next slide, please, Jeroen. Cool. So we've covered a lot of information in this webinar, 4 different ways to design in your CAD software an overstructure, whether you want to do it as an RPD or a denture or a crown with some, a coping rather with some pontics, or you can do it as a hybrid or tie-based structure. There's a lot of workflows involved in that, setting up the order forms, subtle differences. A lot of that's available on YouTube, but also if you do have any questions, please reach out to us. This is what we do. This is our specialty in dentistry, knowing these CAD/CAM workflows. This is where we can help you. So if you do want to know more or want to learn how to design and manufacture yourself, maybe you're already milling a denture base, but you want to think about milling some denture teeth. They're a bit more delicate. Maybe you want some help with your strategies. Maybe you want to look at getting some Ceremco material so you don't mill anymore, you can print instead. Please reach out to us, book your personal training session with one of our trainers, or you can also look at us on Facebook, Instagram, LinkedIn, our website. If you ever have any questions about support, we've got a new chat function on our website as well. You can go on and live chat to someone. We have staff here in Sydney like myself, Jeroen's in Melbourne, we have other people in Zurich and Toronto. So if you're in Australia and you're up at 2 AM thinking, what's the best denture material, please reach out and you'll be able to talk to anyone live. Jeroen, thank you very much for joining me in this webinar. It's been excellent to tag team with you and talk about these really interesting workflows that are getting really, really popular. In the support team, we're getting many questions about how can I take the workflows I've done before and bring them into 2020. I see these new workflows online. I think it's really exciting.
Definitely, definitely. Well, thank you, Matthew, for explaining us a lot about the digital manufacturing, and especially about 3D milling and 3D printing. So really thank you for enlightening us with your knowledge on that one. And I know for sure there are a lot of people who want to know more about it or want to do the next step And like Matthew said previously, please reach out to us. We're specialized in digital workflows, but also like adapting strategies, adapting milling strategies, or anything else. We're more than happy to support you wherever we can. So if there are any questions, we're not doing a question and answer session in this one because there might be so many complicated questions. We rather do it personal because to also understand better your workflows.
Exactly.
Yeah, I think that is very important to really understand someone's workflow, to give the right advice and the right support. So thank you for all tuning in. If there is anything, please feel free to reach out to us. Have a great day, and please all stay safe.
Thanks, everyone. Bye.